Hello there. In this lesson, we'll be talking about refraction. It is a physical phenomenon that has many important applications in real life. So what is ray optics? Light has many properties. It reflects, scatters, refracts, disperses, and can do so much more. Ray optics is one of the theories that is used to understand the relatively simpler properties of light, like reflection and refraction. In this theory, light can be represented with simple geometric lines. That's it. There were three applications of refraction going on in that moment. My friend's eyes being able to see the camera being able to detect my friend's face, and the fact that he was using an internet connection provided by fiber optics. Let us take a look at the first two applications. Both of these optical instruments use lenses to create an image on a photosensitive element. These lenses are made up of transparent materials with two spherical surfaces. The two main types of lenses are convex lenses and concave lenses. Now we are going to take a look at some naming conventions. The center of the lens is called the optical center. Since these lenses have two curved surfaces, there are two centers of curvature. The line joining these centers of curvatures is called the principal axis, which we consider to be the x-axis. Now, this is how light parallel to the principal axis behaves in both of these lenses. When these light rays enter a lens, they get refracted twice. When they meet at one point, it is called convergence. When they move outward, it is called divergence. The point F is called the focal length of the image. This is the point where the light rays converge. But in the concave lens, it is the point where the light rays appear to converge from the right hand side. This is an important distinction because let's see what happens when we put objects in front of these lenses. Here U is the distance between the object and the lens. Let's take two rays. One parallel to the axis which bends inwards after refraction, and another one passing right through the lens. This one doesn't bend. The image formed is real and it's inverted. If the same scenario is repeated in the concave lens, there is no convergence of light. So we won't have a real image. But from the other side of the lens, the rays seem to be converging at this point. This gives us a virtual image. The distance between the image and the lens is labeled V. To make a lens, the math involved is represented by this important equation. This allows lens makers to decide the parameters to consider to make a lens of a required focal length. Now back to our example of the human eye and the camera. They both use lenses to create images on a photosensitive element. Our eyes have a convex lens. The photosensitive element in our eyes is the retina, whereas in a digital camera it is a bunch of electronic sensors. These photosensitive elements are responsible for detecting the incoming light from an object and creating an image for us to see. So you see, light is important to create an image. This is why it is really hard to see anything in pitch black darkness. So to briefly summarize this lesson, ray optics is a study of light in which light waves are represented as geometric lines or rays. And refraction is the property of light to bend when it crosses the interface of two media with different refractive indices.